In May 1990, the partial skeleton and remains of a man were found submerged in water. The hands and feet were missing. A post-mortem at the time revealed he'd broken his collarbone and ribs. Teeth stains suggested he was a smoker, aged between 40 and 60.
They did as much as possible at the time. DNA was not successful.
Dental records back then weren't of the same standard. Often dentists didn't take that many x-rays.
We've all seen television drama about forensics and the missing. In reality, human identification is vastly more complicated. This is the mortuary at the Victorian Institute of Forensic Medicine. And stored on site here are the remains of many people who have still never been identified. They're potentially people's mothers, fathers, brothers, sisters, and yet at the moment, they're nothing more than case numbers. But soon, this may all change.
We might be able to, in the future, build up a 3D image of what the person may have looked like.
In this episode, we're going to investigate a real-life unsolved mystery and reveal how cutting-edge forensics, together with developments in DNA testing, are working towards, quite literally, putting a face to the nameless.
The worst thing is really just not knowing. It's like a horrible gothic merry-go-round that just won't stop.
In 1991, Dylan Redmon's 25-year-old brother, Owen, left for work, and he was never seen again.
There were times that he would kind of take off and he'd go to different festivals and, and see bands, and he'd just go off and do his own thing. But he started just backing off from everyone.
It's a heartbreaking and familiar story for thousands of families every year around the country.
And he didn't take anything really valuable with him.
Someone they love goes missing without any clues. For Dylan, it's been decades of false hope and the anguish of not knowing.
The worst case scenario is that he's passed away, he's died somewhere, and no one's
We know the skeletal remains are not those of Dylan's brother, Owen. Solving the questions around those remains is up to these people. They're the team from the Centre for Human Identification, part of the Victorian Institute of Forensic Medicine. Formed in response to the tragedy of the Bali bombings in 2002, the team's been involved in victim identification from disasters like the Black Saturday fires, the Boxing Day tsunami, and most recently, MH17.
The main task is to assist coronial investigations, particularly when there's a question around identification of the person. So if the person can't be visually identified because, for example, of facial trauma, then we need to resort to scientific means of identification.
They're specialists in fields of anthropology, pathology, molecular biology, and odontology. In 1990, there was little information available to identify those Riverside remains. No fingerprints, no dental records, and no conclusive DNA analysis.
Things were not as advanced as they were now, but some notes were made about this set of remains.
Fast forward to 2007. Evidence of bungles and failures in paperwork drove detectives to reopen hundreds of cold case files, all with the hope of matching the missing to the dead.
The police had an idea who this person may have been, and therefore what they were trying to do is recover a good DNA sample from the remains that we could get a profile for, and then compare those to samples that had been provided by family members.
This doesn't look much like a cemetery. There are no headstones, in fact no identification at all for many of the people who are buried here. But it's in this public burial area that the unidentified remains were eventually laid to rest. Then, decades later, ordered to be exhumed. With the hope of new clues to an identity, it's forensic anthropologist Dr. Soren Blau who begins the process of piecing together information.
What we're trying to do with forensic anthropology is to really narrow down the field.
Along with forensic pathologist Dr. Paul Bedford, they perform an anatomical stock take to make sure the right person has been exhumed.
Thoracic 1 to 12, correct. Lumbar 1 to 5.
The examination of the biological profile of this individual indicated that the individual was male. He was of an ancestry of Caucasoid, so of a European ancestry, and he was an elderly male.
CT scanning wasn't being used in the 90s for post-mortems. Now it's become one of the most important additions to the forensic medicine kit.
So this time we were able to CT scan them, we were able to do much more detailed recording of the dental status, try to compare that to antemortem information.
Examiners are now more likely to use a mouse than a scalpel.
CT scanner has had a massive impact on how we do our work here. So every deceased person that comes into the building has a full body head-to-toe CT scan. We CT scan not only fleshed bodies and normal people, but also skeletal remains. There's stuff inside the bones that we can't necessarily see that we can see on a CT scan.
More objective than traditional post-mortems, these virtual autopsies create a permanent set of digital data that can be reviewed at any time, particularly when new evidence comes to light.
We'll get a CT scan of an unknown skull, and we'll get some photographs of the living people who that skull may belong to, and we'll use some computer techniques to insert the skull inside the head and see if it fits. It's as simple as that.
It's called craniofacial superimposition.
We can never use it to actually identify someone, but we can use it to include or exclude someone as a possible owner of that skull.
And in the name of science, I've volunteered my photo to demonstrate.
So what I've done with your photograph is I've gone through our CT database and found a skull that kind of fits. And I've imported that into this program to see how well or badly the skull can fit.
But with that, you can do quite a good physical match there just with the eye.
Yeah, that's right, just with the eyes and the widths of the cheekbones. And looking at that, you'd think, well, yeah, that's a possibility.
But it's the lateral image that clearly shows I'm not a match.
So in this case, I would say, well, no, this skull cannot possibly belong to Graham Phillips, and you will be discounted from one of the possibles. So it's an idea of exclusion leading to a smaller and smaller pool of people.
And for you social media skeptics, those smiling Facebook selfies have found a place in forensics.
This is a real case that we did. So we have the CT scan of the person's mouth region, and we can use some computer software to extract the densest pixels out of that CT data. And when you do that, we have just the teeth, and you can see this person has a slightly rotated lateral incisor, rotated lateral incisor, slightly crooked front teeth, slightly crooked front teeth. So you can see that, and then we can get to the stage where we're superimposing
So it's a perfect
of the
match.
teeth that are there, and we can look at that and say, well, that's as close to a perfect match as we can get.
Unfortunately, without any useful photos or dental x-rays before he died, no amount of imaging could shed any light on the identity of the remains.
Just a bit of proximal cleaning for the DNA.
It was time to revert to the gold standard for human identification, DNA testing. By taking a small piece of bone and some clever genome analysis, it's over to molecular biologist Dr. Dadna Hartman. She'll work out if it's a match to a DNA sample provided by a desperate family. Those twisted strands of molecules are encoded with a language made up of 4 base pairs that speaks for you and about you.
What we're looking at is nuclear DNA analysis, and what we're targeting are regions of the DNA that are really useful for identification purposes.
The regions are called short tandem repeats, or STRs. They are short sequences of DNA building blocks, or nucleotides, repeated many times. These repeats differ from person to person and give us our unique profile. By examining the STR locations on the genome, scientists can tell how likely a match is between two samples. The more sites that match in repeat number, the more likely it is that the people are related.
So Graham, this is where we do the extraction of DNA from things like skeletal remains. So it's a section of the femur. Now the methodology is so that we can probably start with a lot less bone to get a profile, because in some cases we don't have a nice beautiful chunk of femur to work with.
Nowadays, a tiny piece of bone can be converted into a lot of information.
So at the moment we're looking at 15 regions of DNA. When you combine that information together, it makes it highly unlikely that two individuals will have the same profile by sheer chance.
And, in Victoria at least, the system processing that information comes straight from the FBI. It's called CODIS, Combined DNA Index System, a software that allows matching at lightning speeds.
During the 2009 bushfires, we needed some sort of software capability to enable us to do DNA matching, to identify those that were perished during the bushfires to family members who had provided samples. You can imagine if we were to do that manually or using spreadsheets, it would take hours, days, weeks to be able to do that.
Since 2010, CODIS has provided successful matches that otherwise would never have been made.
So it enables us to store profile information from individuals, whether they be DNA profiles from unidentified remains or family members. So what we have done is generated a mock profile for yourself.
My dad's square, my mum's round.
Yes. So we would then search your profile and hope that it matches.
And that's a match.
It is.
That's incredibly fast. And so I guess you can kind of imagine the time where all the data you have will be in one system and you could do the match with one click of a button.
Correct. We're not there yet, but yes, that would be fantastic.
More than 30 years on, there's still no finality for Dylan. His DNA profile is on the Victorian database and he's making sure Owen is not forgotten.
So I wanted to try and reach, as many people as I could, because there'll be one person somewhere who knows what's happened.
But what of the family hoping for a DNA match to that mystery man?
We were able to successfully get a DNA profile from those remains. We were then able to compare them to the DNA profiles from family members. Unfortunately, in this case, they were not a match, so the DNA evidence suggested to us that the actual set of remains was not the biological relative of the person. We now have a DNA profile for those remains, and we are able to add that to the Victorian Missing Persons DNA database in the hope that in the future, as reference samples has become available for other missing persons, we might have a match.
With no more reference samples available, that's the end of the road for those remains. Or is it? What if it were possible to take a sample of DNA from the remains and reconstruct a full colour photograph of the person? Well, that's what I've come to the University of Canberra to find out about. Dr. Dennis McNiven is a forensic geneticist. He's working on predicting a person's appearance from anonymous DNA.
At the moment, we can, with a reasonable degree of accuracy, predict your continental level ancestry. We can reasonably predict eye colour and hair colour.
These traits are known as phenotypes, and they can be extracted from our genetic code using things known as SNPs, single nucleotide polymorphisms. They're areas of the human genome that differ by one building block from person to person. Unlike STRs, it's the sequence of the building blocks, not the length, that's useful for forensic scientists. Some people might have an A at one point, while some others might have a C. This difference gives us a microscopic insight into what we look like, from eye colour to hair colour, even where our ancestors came from.
All
right, so you're going to find out my secrets, are you?
I am.
All it takes is a simple saliva swab. So just like this?
That's it.
And a few days to process.
So here's your results. And you can see that your DNA is represented by this red dot here.
Yeah.
And it's right in the middle of a cluster of purple dots. And these purple dots represent Europeans. So this is telling us that you are essentially European. much more likely to be European than any other continental grouping.
Okay, so that's what I thought.
So no
there's no
surprises
surprises in the family tree. That is a relief.
Now we can also see what it's saying about your hair and your eye colour.
Yeah.
So you can see that we've got 4 categories of hair colour: brown, red, black and blonde, and you've come out as 65% brown with perhaps some black as well. And this is your eye colour. So you can see that, again, we have 3 categories here. We've got blue, brown and intermediate. And you've come across as not quite any of them. So you haven't got blue eyes, you haven't got brown eyes, so you're somewhere in between.
Good, so there's no genetic surprises there. What a relief.
Well, is that a relief or a disappointment for you?
It's research that gives forensic scientists great hope.
What we could do in the future is potentially do phenotypic analysis of these unidentified remains, so we can start to build a profile of what this person may have looked like when they were, I guess, alive.
The science we've just seen will be really helpful for identifying missing people, but it'll also be invaluable for solving crimes.
If you get DNA from a crime scene and you don't get a match with another person, well, that's a dead end. But now we have the ability to extract further information from that DNA. If you like, to let the DNA do the talking, to extract the silent witness, and to build a picture of what the donor of that DNA may have looked like.
In this promotional video, a US company suggests its software tool is already assisting law enforcement.
As the program sifts through millions of pieces of genetic information, it slowly begins to build a suspect's appearance.
They claim they can generate images to narrow down suspect lists and unidentified remains with a high degree of accuracy. In Australia, Dr. Mark Barash is trying to hone the accuracy of facial images by analysing more than 1,000 volunteers.
Ultimately, I would like to produce a comprehensive molecular identikit, which will include information about the visual appearance.
To do that, he takes a sample for DNA processing and a 3D photograph, which he analyses to measure facial landmarks. Sophisticated algorithms match DNA with physical traits. Dr. Barash has already examined samples from more than 600 people, discovering strong links to more than 6,000 genetic markers and 100 facial traits. The numbers we see are the craniofacial landmarks, and the traits are represented by the distance between them. Undoubtedly, genomic profiling is a game changer for future forensics.
The more we learn about, I guess, the genetics behind our features, our phenotypic features, we might be able to, in the future, build up a 3D image of what the person may have looked like in life from the DNA profile.
Dylan's search for his missing brother has new science on his side.
Just to know, even if it was, I'm still alive, it's too awkward, I can't do this, but I'm okay.
Now, all he needs is resolution.
The worst thing is really just not knowing.